Greetings Internet, today as promised let's have a little bit of a look at the behind the scenes of how modular synth stuff works. I should start off by pointing out that if you're not one of my subscribers and have just stumbled upon this video searching for VEDA' tutorials, this is probably not going to be the video for you. I know very little about how all this works yet. I've been tinkering for a few months on and off, but you know, there is a lot of stuff I do not know how this works. I just thought it would be an interesting challenge to fill a day of trying to make a video every day in April to try and explain the very basics. If you're looking for an actual tutorial, I would suggest you look elsewhere. I will link on the end screen and down in the doobly-doo to a couple of videos that sort of inspired me and made it click in my head, and as to that sort of how I realised that this was a thing that I wanted to try and learn. They're not exactly tutorials, but it gives you more of a sort of introduction, but from someone who knows what they're talking about. So what is a modular synth? Well, it's, you know, obviously some kind of sound that is put together with multiple individual modules. Each of those modules is connected together with cables, and that's the like very basic concept. We've got 3 modules on screen at the moment, which are basically just needed to output the audio. There's a mixer which can take various sound inputs and give them volume levels. There's a audio output which connects everything to my headphones, and there's a oscilloscope which, you know, just shows us the waveform of the output. So let's get me out of the way and then start looking about adding modules. As mentioned, sort of all sound is basically just a waveform, and these things are, you know, just sort of electrically sort of generate waves which can then be output as sound. So what we would start with is what's known as an oscillator. That's basically the core of all this. It's like, if this were hardware, there'd be some kind of crystal in there making a waveform signal, but obviously this is emulated in software. If we take the output of that module and connect it to our mixer, we will hear that wave as a tone. We can alter the frequency of that wave, which changes the pitch. We can alter the actual shape of that wave, which changes the sort of how it sounds. So you've got a full-on square wave down to a sawtooth or a sine, I guess is that one. And yeah, they all have slight different audio properties. And you know, you can just play a tune by fiddling with the frequency knob. We can do all sorts of things with this sound by adding more modules. So for example, we could add a delay on the end of that. So instead of taking the output of the wave, the oscillator, right into the mixer, we'll put that into the delay, and then the output of the delay goes to the mixer. And now it has a bit of an echoey effect on top, and maybe with a bit more feedback. And so every time the note begins, you get more of an echo on it. Then maybe what else could we add? Maybe a bit of a reverb to sound like it's sort of echoing in a bigger room. So again, we'll change where our output goes, and then we'll change the output of that one. Increase that a bit to give it a bit, spin things around a bit, and now everything's a bit more echoey. And so you just start fiddling with knobs until you produce interesting sounds. So what else can we do with this sound at this point? Now, there's the one interesting thing, of course, that you can do is if we connect this up to a MIDI source, then I can simply play that sound. But, you know, as someone who is terrible at playing the keyboard, that was never really the interesting part of this for me. I was always more interested in the ability that it had to use, you know, pseudo-random stuff to play itself. So let's get rid of the MIDI input and those weird echoey things and go back to a basic tone. So, you know, we can play this oscillator by fiddling with the frequency knob, but what if we wanted to get something to do that for us? Well, we can actually do that by just, you know, adding another oscillator. Because everything in this is controlled by voltages. So this oscillator is making an oscillating signal, but rather than connecting this one directly to the mixer, if we connect the output of this to the voltage controlled octave of this one, then that signal is now controlling the pitch. If we slow it down a bit, you can, maybe a bit more, you can see the voltage going up and down in the sine wave that we connected to it. You know, if we connect it to the square wave, it's just jumping between 0 and 10. And I have apparently made a phone call noise. Or, you know, sawtooth, it could do up, drop, up, drop. But again, that's only a very it's a basic, very oscillating thing. If we want to take that further, then we need something a bit more complicated. And then have a look at where are they? Sequencer. Now with this you'll see this has a tempo that's currently running at 120 beats per minute, as shown by that light. And you can see a little light following each of these outputs. But if we take the the voltage output of this and bring it into our tone, that means that each time the light is on a certain column, the value of the dial on this row here is going to be change the frequency of this oscillator. So you know, if we start fiddling with these dials a bit, you start to get a bit of a tune. And this particular sequencer has 3 rows of dials, so we could add another oscillator. Let's add one of these. We'll connect that to channel 2. Throw that on the mixer. Wiggle our dials again. And yeah, we have a bit of a tune. It's a very discordant mess, but you know, it's part of the process of sort of developing a sound. So how can we make that sound a little bit nicer? Well, if you look at the tooltip here, you'll see that this is all an amount of voltage which is controlled by whatever setting is on these dials. The problem is the basic known human musical scales that you're familiar with you know, don't cover the entire range. There are steps. So what we can do is introduce what's called a quantizer. We'll add both of those, one of those before each of these. Move the inputs into that, and then the quantizers into there. And then now, the voltage going into the quantizer is sort of rounded to the nearest known actual musical note. And we can control what notes it plays exactly. So, you know, if I turn off the black keys, it should stick fairly major. And now you're starting to get something. But still, this is a particular sequence that I have set, and it's only 8 notes repeating in a loop forever and ever, then that's not particularly interesting. So what if we do something that's a lot more random? And for that, you know, there are other sequencer type things. I think they're sequencers. Yeah, this is one I like to use. So we'll add a couple of those. And if we take the note output of this into our quantizers, you will notice at this point that it's not actually doing anything. And that's because, unlike the sequencer we had on before, this one doesn't have its own internal clock speed. So we're going to need to add our own oscillator, a low frequency oscillator for this. So, you know, this one has its own frequency, which we can then use as a clock input for both of these. And then now you'll see, as this goes, that these lights move, and if we change the frequency of our oscillator, that speeds everything up. So if we just select both of these to start in random sequences. Oh right, I was going to say it didn't sound like this bottom one is changing much, and that's because I've got this plugged into the wrong thing. But now we still have a similar problem to the sequencer, in that this has picked a random 16-note sequence and is just going to keep that on repeat. We can set these to be completely random, but that's get a bit of weird musically. What your brain really likes is to hear patterns, so instead of being completely random, we need to do something that's a bit in between. So we're going to add... we want to add a clock divider. That one. So again, we're going to add the clock speed so that everything's linked to the same base tempo. But then this sends out signals at subdivisions of that clock speed. So if we then click one of those, or connect one of those outputs to the mutate function of this random thing, that means it will play. So now it picks a random sequence of notes, it plays them for a bit, and then it'll pick another random set of notes once it gets the trigger to mutate. Because everything is related to the main base low frequency oscillator, we can, you know, if we want this to go faster, we can just speed everything up. And then we can just quickly do some other bits. Let's no, not that one. One of them, right. So there, we'll get that synced with the clock, and that's now doing a weird thing, and then we'll throw in, just because some drum modules will have a kick. Oh, come down here. Kick, a snare, and a hi-hat. Obviously, the drum sounds are, again, just drum sounds, and if you connect a wave to the various envelope generators and different sound processing things, you can actually create your own drum sound. But there are also modules available, so you don't have to do that. So if we have a trigger a kick on, a kick on one beat, and then we'll add a quick snare on another. And then a hi-hat on everything. Or maybe even a bit more. And because we're using the synth clock, although it's a half speed, if we want to slow things down. And yes, admittedly, that sounds like an utter mess because I wasn't really thinking about it and really doing quite quickly, but it just gives you a bit of an idea of what you can do with this. And just like these random modules, these drum triggers can be set to random, which also can make some interesting effects. We might need a bit more. The half clock speed's killing us. Let's double that up. And that is basically about it. You sort of fiddle with all the knobs and put things together, and eventually it maybe sounds like music. I definitely still have a lot to learn. There are a lot of these modules that I really honestly don't know what they're for. But yeah, if you want to hear it explained by someone who actually knows what they're talking about, I will link to a video at the end by Andrew Huang and Rob Scallon, which is what got me interested into this. And if you made it to the end, thank you very much for watching, and I will see you again tomorrow.